In today's note, we're going to be reviewing the three different forms of factoring. So as we can see here, this is just the homework from the past couple lessons where we looked at common factoring, factoring a difference of squares, and factoring a trinomial or x squared plus bx plus 3. So again, this is just the homework questions. So if you haven't worked through these and you still want to review, I would suggest going back and working through these questions. There is a worksheet that you'll find online in the course that has extra questions as well. So we're just going to review the three different forms. So starting off is common factoring. So common factoring that we're just going to signal with CF just for this note. Again, common factoring is where you just find the greatest common factor, or the GCF. So again, that's the largest term that goes into our expression. So if I look at, for example, this first part here, 3x plus 6, the greatest common factor in both 3x and 6 is 3, which we have here. So what happens, so that's our GCF. So what happens once we find our greatest common factor, we remove that from the expression by taking it out and then dividing everything else by it. So we can see the 3, or the greatest common factor, has come out. I've put the rest of the terms in brackets and I've divided everything by 3. 3x divided by 3 is x. 6 divided by 3 is 2. We can see the same thing in the next example, where we have negative 4x squared plus 12x, and we found our greatest common factor to be negative 4x. So again, remember, a greatest common factor can also have a variable in it, because if we look back, that is common between the 4x squared and the 12x. The 4 is also common between 4 and 12. And usually a general rule of thumb, if the first number in our expression is negative, like the negative 4, we take out the negative number as well to leave us with a positive there. So that means that when I divide negative 4x squared by my greatest common factor, I'm left with x. And when I divide 12x by my greatest common factor, I'm left with negative 3. Number 2, difference of squares. We're going to use ds to help us identify that. Remember, difference of squares followed the pattern where it was a squared minus b squared, which then turned into x minus a minus b times a plus b. So here we had to look for roots or perfect squares. And if you refer back to that note, at the end of it, we looked through examples of perfect squares. So you're going to look for perfect squares. Basically, if you take the square root of that number, do you get a nice number in the end? So if I look at the first one, I see x squared minus 9. Oh, another thing, only 2 terms. 2 terms only, and their subtraction. That's another key thing. So 2 terms only, subtraction. Basically, it's the pattern a squared minus b squared becomes a minus b times a plus b, and we're looking for perfect squares. So we have 2 terms, x squared and minus 9, good. There is a subtraction in there, which is good. Now, are they perfect squares? Well, I can take the square root of x squared and it becomes x, and I can take the square root of 9 and it becomes 3. So those are perfect squares, so that's where they become. So if this is my a squared and b squared, I can now see that this is my a and b. So the square root of both of these 2 terms here go into my brackets, and one is positive and one is negative. If I look at the next example, 64 minus x squared, if you take the square root of 64, you realize you get 8, which is a nice number. It's nice and round. And if you take the square root of x squared, we saw in the last example that that is a perfect square as well. So then we can take our 2 answers and put them into the brackets, one adding, one subtracting. So a simple trinomial, or the x squared plus bx plus c, we're going to use st to help us identify that for this note. So this was where we had to look for the product and sum. So that was where two numbers, let's say, I think we said m plus n had to equal b, and m times n has to equal c. And remember, b is the middle number and c is the last number. Again, we also talked about the X puzzle. Where B was bottom, C was top. And again, we just had to figure out two numbers that multiply to C and two numbers that add to B. So again, it's the same thing, just a different way of visualizing it. So if we look at the first example, we're looking for two numbers that add to 6 but multiply to 8. And if we look at the answer, 2 and 4, so 2 plus 4 is 6, 2 times 4 is 8. And then x is always going to be the first term in those brackets. When we look at the next example, we have a b value. We don't see anything in front of that x, but there's always a 1. And then we have c. So we're looking for two numbers that add to -1 but multiply to -12. So in this case, we look at our answers, we have +3 and -4. Those are two answers. +3 plus -4 equals -1. +3 times -4 equals -12. And if you want, go back and look at the note on factoring x squared plus bx plus c. And at the end of the note, you'll see kind of a guideline of what our two numbers should be based on what we're given. So for example, here we had a -b and a -c. We have a negative or a +c and a +b. So looking at those signs, there's little ways we can, or little things we can use to help us figure out what our answers are going to be. So what we're going to do now is we're just going to go through and look at trying to identify which method of factoring works best. So looking through these, and you can refer back to that last page. If we're trying to factor 2x squared plus 10x. So first thing you want to do, is there common factoring? Well, is there a greatest common factor? There is a greatest common factor because we can see that we have 2x squared plus 10x, so the greatest common factor, the greatest factor that can go into both of them, we have is 2 and x. So 2 and x can go into both, so that means this can become 2x, and then in our brackets, x plus 5. So that means this was common factoring, not a difference of squares because there's no subtraction, and not a simple trinomial because there are no three terms. So the next example, we have 3x squared plus 27. So right off the bat, it's not simple trinomial at the end because there's not three terms. Let's check to see if there's a greatest common factor. There is. So the greatest common factor in this case is 3, because 3 goes into both 3x squared and -27. So common factoring. So if I common factor this, I end up with 3 times x squared minus 9. But what we should recognize is that it's also a difference of squares, because now that we've common factored, it does leave us with a difference of squares. And if we do that, the 3 still stays, and we have x plus 3, x minus 3. So we had our common factoring, and then we had our difference of squares. And again, you can refer back to the top or the notes on how we got through those, or how we factored those. C, again, simple trinomial, so there are three terms here. So there's a good bet that it's going to be that, but it doesn't look quite like what we've done before. So let's see what we can do. you always want to check to see if you can common factor first, and in this case we can. I can take a greatest common factor of 4 out, because 4 goes into each term. So this becomes 4 goes on the outside, everything on the inside is divided by 4. We get x squared minus 4x plus 3. And then if I look inside the bracket, that is also a simple trinomial. There are 3 terms there, so I can factor this. The 4 still stays the same, and inside the bracket, I'm looking for 2 numbers that add to -4 but multiply to +3. And I end up with x minus 3 times x minus 1. So I start with common factoring, and then I do simple trinomials. And then I'm finally factored at the end. For D again, I can see a difference of squares here because I see 2 terms in their subtraction. In order to get there though, I do need to common factor first. So again, the greatest common factor that I can take out, in this case, is 5. So this becomes, bring the 5 on the outside, divide everything on the inside by 5. So I get 25 minus x squared. And then this is a difference of squares here. So then I can do the square root of 25 is 5 minus the square root of x squared, which is x, and just repeat with the same numbers, except this one now is going to be plus in the middle. So again, I start off with common factoring, and I have some difference of squares as well. And lastly, E. Again, there's 3 terms here, so there's a good chance it's simple trinomials, but it doesn't quite look like that because I have a number in front of the x squared first. So there's a good chance I have to common factor. Again, you always want to look to see if you can common factor first. So in this case, the greatest common factor is -6. So that means when I factor this, the -6 comes out. Everything on the inside gets divided by -6. So I'm left with x squared plus 5 plus 6, or plus 5x, sorry, plus 6. And then again, inside that bracket, I can see a simple trinomial. So if I factor that, again, simple trinomial means the product and sum, the x puzzle. The -6 stays the same. Now I'm looking for, x goes in first. That's my variable. And now I'm looking for 2 numbers that multiply to 6, but add to 5. So the only 2 numbers that works for is you have to have +3 and +2. 3 plus 2 is 5. 3 times 2 is 6. So those are our 2 numbers that go in there. So again, that was just a quick overview looking at, let me just add, we had common factoring and then we had simple trinomials. So again, just looking at 3 different methods: common factoring, difference of squares, and simple trinomials. You always want to start with common factoring. As you can see here, common factoring was involved in all of them, but then in some cases there was a second step as well. So again, just make sure you're familiar with the 3 methods, and then being able to recognize them when you're given an expression.